In this section, we will be introduced to polynomials. A monomial in one variable is a product of a constant and a variable raised to a whole power. Remember that whole numbers are 0, 1, 2, etc. A monomial in one variable is of the form ax to the k power, where a is a constant, x is a variable, and k is a whole number. The constant a is called the coefficient of the monomial. In a monomial of the form ax to the k power, if a is not equal to 0, then we call k the degree of the monomial. For example, consider the monomial 6x to the third power. The coefficient is a constant, which is 6, and the degree is the exponent, which is 3. A polynomial in one variable is a monomial or the sum of monomials. For example, the polynomial 6x to the fifth plus 3x cubed plus 5x squared plus 3 contains 1, 2, 3, 4 different monomials. The polynomial ab minus a plus b contains 3 different monomials. The polynomial 2 plus c contains 2 different monomials. A polynomial that has 2 monomials that are not like terms is called a binomial. For example, x squared plus 3 is a binomial since it has 2 terms that are not like terms. X minus 4 is a binomial since the polynomial has 2 terms that are not like terms. A polynomial that contains 3 monomials that are not like terms is called a trinomial. For example, x squared minus 3x plus 5 is a trinomial. 4x squared plus 3xy minus 2y squared is also a trinomial. Combining like terms. Monomials with the same variable and degree are like terms and may be added or subtracted. Combine like terms. 4y to the fourth minus 9y to the fourth. Since y to the fourth has the same variable and the same exponent, these are like terms. In order to add or subtract like terms, we add or subtract the coefficients. In this case, 4 minus 9 will be negative 5, and we keep the variable and the exponent unchanged. So when we combine like terms, our answer is negative 5y to the fourth. Next, let's combine like terms. 7x to the fifth plus 9 plus 3x squared plus 6x squared minus 13 minus 6x to the fifth. Like terms have the same variable and same degree. So 7x to the fifth and negative 6x to the fifth are like terms. 7 minus 6 is 1, so our result is 1x to the fifth, or simply x to the fifth. 3x squared and 6x squared are also like terms. 3 plus 6 is 9. When we add or subtract like terms, we keep the variable and the degree the same. So our result will be 9x squared. Then we also have a positive 9 and negative 13 as like terms. They're constants. 9 minus 13 is negative 4. This is the result. X to the fifth plus 9x squared minus 4. Let's combine like terms. We have 5 over 6x cubed minus 2x squared minus 1 over 4x plus 3 minus 2/3 x cubed plus 1 over 6x minus 1/2. Let's start with the highest degree. The highest degree is 5 over 6x cubed minus 2 over 3x cubed. So we have 5 over 6x cubed minus 2 over 3x cubed. We will need to subtract the coefficients 5 over 6 minus 2 over 3. Since these are unlike denominators, we need to get a common denominator. In order to get a common denominator, we can rewrite 2 over 3 using a denominator of 6. For this to happen, we will multiply the 3 and 2 both by 2. This will result in 5 over 6x cubed minus 4 over 6x cubed. Once we have a common denominator, we can subtract the numerators. 5 minus 4 is 1. This will give us 1 over 6x cubed. Notice the x cubed remains unchanged. And because there are many terms, I'm going to cross out the x cubes so I know I used them. Next, we have a negative 2x squared. There are no other x squareds. Therefore, negative 2x squared does not have any like terms that it can combine with. We'll cross it out so I remember that I've used it. Next, we have negative 1 over 4x plus 1 over 6x. Once again, we don't have the same denominator, so in order to get a common denominator, we need to find the least common denominator between 4 and 6, which is 12. Which means I will multiply the 4 and the 1 by 3 in order to rewrite negative 1/4 using a denominator of 12. That's a negative 3 over 12x. I will multiply the 6 by 2 and the 1 by 2. This will give us 2 over 12x. Negative 3 plus 2 is negative 1 over 12x. Finally, let's combine 3 and negative 1/2. Anytime you subtract, add, multiply, or divide an integer with a fraction, remember to rewrite the integer as a fraction by writing it over 1. The common denominator here is 2, so we will multiply the 3 and the 1 by 2. This will give us 6 over 2 minus 1 over 2. Once we have a common denominator, subtract the numerators. This gives us 5 over 2. So our resulting polynomial is 1 over 6x cubed minus 2x squared minus 1 over 12x plus 5/2. To evaluate a polynomial, substitute the given number for the value of the variable and simplify. When replacing a variable with a numerical value, always use parentheses. For example, evaluate the polynomial 3x squared plus 2x plus 4 for x equals to negative 4, which means each x value will be replaced with negative 4, but be sure to use parentheses. So we have 3 times negative 4 to the second power plus 2 times negative 4 plus 4. In the order of operations, simplify the parentheses first, but the parentheses cannot be simplified. Then simplify the exponent. Negative 4 squared is 16. This gives us 3 times 16 plus 2 times negative 4 plus 4. 3 times 16 is 48 minus 8 plus 4. This will give us 40 plus 4, which is 44.